notice is you have variables on the top and the bottom. And there's no quotient rule for integration. The quotient rule only exists for differentiation. So what we do is we do substitutions, okay? And the deal is with the substitutions is we generally let the more complicated one be the substitution. So I have a choice. I can do u equals x or u equals x squared plus 2. Which one's considered the more complicated one? Exactly. And what you'll notice is when I differentiate it, I do du dx. What pops out then? 2x. And you see this x dx part? I'm looking to form x dx on its own. So I bring up the dx, and where do I put the 2 then? The 2 was here, yeah? I'm going to bring it underneath the du and turn it into a half. Now what we're doing is we're doing wholesale substitution here. Don't worry about the limits for the time being. We're going to put everything back where it started from, okay? So what we're going to do is we're going to do x dx turns into half du. The x squared plus 2 turns into u. Happy enough with that? We're allowed to bring a constant outside, aren't we? Half the integral of 1 over u du. Now what is that? What happens when you integrate 1 over u? ln u. There would be a plus c here, but because the original question has limits, I'm not going to do that, okay? And then what can I change u back into? So my answer is a half ln x squared plus 2, and my limits are 2 and 0. And then this means it's going to be substitute into, so it's going to be a half ln, what's 2 squared plus 2? ln 6, yeah, minus a half ln 2. Now, what? In a second will be. I'm factorising out the half. What's ln 6 take away ln 2? Using the division rule of logs. It's ln 3. So it's a half ln 3. Some people might bring in up the half and say it's ln root 3. Did I make a mistake? Oh. No, x squared, buddy. 0 squared plus 2. Sorry. So you have a choice. Now, can anybody tell me, my options are u equals x plus 1 or u equals, I'm just going to multiply out that power, is that okay? X squared plus, I don't think that's a good idea because if I differentiate that, what happens? Maybe it is a good idea, let's find out. What happens if I differentiate it? It's definitely the more complicated one, isn't it? So what do we get? Ex squared plus 2x, yeah? Oh. No, we're differentiating though. So the 2x plus 2, the derivative of the power is at the front. That will actually work, believe it or not. Because what does 2x plus 2 and x plus 1 have in common? What happens if I half it? A half x plus 1 e to the power of x squared plus 2x. Do you see that? And then what happens to the dx? Into the corner. And then, see that half? What can I do with it? So it's basically 2 du then, isn't it? Wait. I messed that up. Excuse me. I totally messed that up. That shouldn't be a half. That should be 2 times x, 2x, 2 times 2. So the 2 actually goes on the bottom. Cool with that? So what's the next step then when I'm looking up at this and I have all this information on my right hand side? What do you reckon? It is? Huh? No, no, sorry, I never used that one. I used the second one, didn't I? So I think that this red part is u. This blue part, which is it's that, isn't it? And we got rid of that two, didn't we? We brought the two underneath. So what can I sub out that blue part with? Oh, there's an E there. So there's an extra E, isn't there? Hmm. Hmm. What I'm thinking is maybe I don't sub that out with you. See that? See that red one? Maybe the whole thing's a half to you, isn't it? There's more than one way doing this as well. Okay. What number is this? 9, is it? Okay. So in their solution, they made the power, just the power, the u value. Okay, but I think this will work out the same way. So uh, no limits at the moment because they're the limits. They're the limits for x, not for u. And once when we do that, it's going to be a half x. Okay. Oh, sorry, not half x, a half u. Yeah. And what is a half u? We set it up here. And we have a right. That's perfect. And the whole thing is from 0 to -2. So what do we get? A uh, half E0 plus, oh, just E0, isn't it? Because that's all the power. So just a half, yeah. And then the other one, minus a half. Insert -2, you get 4. Insert -2, you get -4. So that's also, and the answer is 0. So the more complicated version is the u value on the bottom, 3x squared plus 1. We did the u dx, and what we got was 3x squared. We want to isolate x squared dx, so we bring the 3 downwards and we say a third du, bring the dx up equals x squared dx. We integrated a third du. Is that what you guys got? Well, you brought the third out, you can if you want, yeah. And you just get u over 3 or third u. Don't, and then we're not bothering with the plus. Oh yes, there's a u on the bottom. A third a third yeah, u's on the bottom, yeah. Some people took the 1/3 out, left it like that. That turns that into an ln answer, doesn't it? A third ln u. There would be a plus c there, but what do we say x was in the first place? Or u, what u was? So see that u, I'm going to change it with. And then I'm going to wrap it in the two brackets, which are 1 and 0. I think we're in business now. We're going to get a third ln 1 plus 1, which is 2, minus a third ln 0 plus 1, which is ln 1. And we all know that ln 1 is... Use your calculator, ln 1. ln 1 0, so it doesn't matter. So our answer is 1/3 ln 2.